when life and death both serve like slaves. To be alive and fight that slavery is bliss, and to be young is to be the knights of that battle. This was the idealism that fueled the lives of millions of Bengalis in the early years of the 20th century. There were several reasons for this, but the foremost among these was the partition of Bengal, the division of their motherland.
It was 1905. Lord Curzon, the then Viceroy of India, divided Bengal. The sentiments of millions of Bengalis who lived in unity did not count much against the administrative convenience of this Viceroy. For an arrogant, haughty administrator coming from an elite class in England, the partition was nothing but a simple stroke of a pen. Hardly would he realize that land is not just a means of existence, much less a tool to make money.
It is an identity for the people who live on it. When it is divided, it is the very identity of the people that is called into question.
But Bengalis would not take it that easily. Trouble broke out, and Curzon was forced to abrogate his decree in 1911.
But that was just a small concession to a larger enslavement of the entire country.
It was this larger and deep-rooted enslavement that gave rise to strong nationalist sentiments. There was a great energy springing from this. It was as if the whole nation was groaning under the weight of foreign domination. A domination not only in the political domain, but economic, cultural, and academic spheres as well. In the academic field, Europe was making great strides. India, with its fledgling academic infrastructure, largely meant to cater to the commercial interests of the crown, could hardly venture into fields that European scientists did.
But in the minds of all, there was the feeling that we Indians can do what the others have done, and perhaps even better. But we have to go back a little in time to understand the real situation. It was the culmination of the efforts of great people like Raja Ram Mohan Roy, Ishwar Chandra Vidyasagar, Michael Madhusudhan Dotto, Keshav Chandra Sen. It was the high noon of Rabindranath Thakur, Brahmabandhu Upadhyay, Rajendranath Sheel, and Swami Vivekananda. It was the time of great scientists like J.C. Bose, B.C. Ray, C.V. Raman. It was the zenith of politicians and educators like Ashutosh Mukherjee, Dr. Mohendralal Sarkar, Rashbihari Ghosh, Taraknath Palit.
And above all, it was a time of the Swadeshi movement, a time when people realized the importance of being Indian, and yet were unable due to the foreign hegemony. Into such a charged atmosphere was born a boy on the first day of January 1894 in this very house. He was named Satyendranath. His father was Surendranath Bose and mother Amodini Devi. True to his name, Satyendra, truth he would seek, and truth he would find like nobody else did before him.
But it was a curious year for India, and especially for Bengal. In that period, between the middle of 1893 and the middle of 1894, were born a number of others. Prashanta Chandra Mahalanobish, Meghnad Shaha, Gyan Chandra Ghosh, and finally Satyendranath Bose, all destined to become great scientists, great men.
Bose studied in the Hindu school. Already in his school days, he showed remarkable dexterity with mathematics. Once, his teacher was so happy that he gave him 110 marks out of 100 because he had solved all the given problems correctly in more than one way. But it is here in Presidency College that Bose showed his talents. He studied mixed mathematics with Meghnad Saha. This mark sheet of Bose bears ample witness to it. This is a record that is not broken even to this day.
But getting good marks is not enough. He wanted a job, and there weren't many for mathematicians. Sir Ashutosh Mukherjee was already a man of great stature, both in the academic and political fields. He would have a great role to play in Bose's life later, and the foundation of it was already being laid in the form of the University College of Science. This institution was a great milestone in Bengal. It symbolized not only the academic independence of the Indians, but stood as a monument of challenge to the British in many ways. Down the portals of this institution would walk great men of science. Shotendranath Bose would be one of them.
These two men, together with Sir Ashutosh, made it possible. This is Taraknath Palit. He donated his entire property to the university for the Science College. And Sir Rash Bihari Ghosh paid 1 million rupees in those days as a first installment. Patriots as they were, they had laid down just one condition. All the appointees must be Indians. This, of course, irked the British. Dr. Prafulla Mitra, a man of chemistry, supervised the construction of the building. Acharya Prafulla Chandra Ray had established himself as a great man in chemistry. This perhaps influenced the building of the Science College, largely meant to develop the Department of Chemistry. That is perhaps why all the rooms in this building have drains.
But chemistry is not a strange discipline to the Bose family. Though Shotendranath Bose is known for his works in physics, his father had started the Indian chemical and pharmaceutical works which preceded the more famous Bengal chemicals of Acharya Prafulla Chandra Rai. Acharya Rai taught in this building and lived in a room on the first floor. Food was brought to him here. In the evening, he would go for a compass carriage ride to the Maidan. There they would discuss various things, including the war strategies of the Germans. But the British government was not very comfortable with this because it was an occasion for the Acharya to talk of nationalism as well.
Once the college was established, Sir Ashutosh was looking for teachers. But teachers, that too Indian teachers, were hard to find. Shoilane Ghosh was a classmate of Bose and Saha. He had stood first in physics from Presidency College. One day, at the instance of Shoilane Ghosh, Sir Ashutosh called Meghnad Saha, Shoilane Ghosh, and Satyendranath Bose. As Bose recalls,
Meghnad, Shoilan and I went up the steep stairs to the library, to the special chamber where Sir Ashutosh sat. We were meek and submissive, and were overawed by his august presence. Sir Ashutosh asked, "What subjects are you competent to teach, boys?" "Sir, we will try our best to teach whatever you want us to."
but that was more easily said than done. As Bose recalls,
We had only heard of the many new discoveries in physics, most of them made in Germany. Planck, Einstein, Bohr. We Bengalis had only heard of them. To know more about them, one had to read German books or research journals in other languages. During the war, most of these journals did not come to India.
nevertheless, Bose was given the job of teaching Einstein's relativity theory. Saha was asked to study quantum theory. As Bose says,
We came away committing ourselves to teach within a year. But where were we to get the books from?
there was just one answer. Dr. Brule, who was then teaching at the Bengal Engineering College at Shibpur. He not only had many of the books that were very much needed, but had set up many delicate instruments which even the Presidency College did not have. Saha had already learned some German by that time. Bose knew French. So they started studying whatever they could lay their hands on. This resulted in the first ever collection of the English translation of Einstein's main papers on relativity. P.C. Mahalanobis, who was then teaching relativity in Presidency College, wrote a preface, and the University of Calcutta published it as a book. Bose and Saha started their study of the subject in 1917. Hardly 3 years later, Saha would become a world-famous figure, opening up a new field of study, quantitative astrophysics. And Bose would join that rank 2 years later.
The postgraduate courses at the Science College did not come that easy. It was the stronghold of the chemistry people. Sir Ashutosh had to win over Acharya Prafulla Chandra Rai. Rai had great confidence in the youth, particularly because of one chemist, J.C. Ghosh, a classmate of Bose and Shaha. Ghosh had already taken the first steps towards developing his famous theory of electrolytic conduction, which was being highly acclaimed in Europe. In fact, Planck, in the preface to his book on thermodynamics, mentioned Ghosh's work. Ghosh would convince Acharya Ray about the capabilities of his classmates.
Impressed by the works of these young men, barely in their 20s, and yet standing at the threshold of world fame, Ray agreed to the introduction of physics in the Science College. Ray was a man who realized the need of the hour very well. What was essential for him, and many like him, was to show that Indians are as capable as the British. So in spite of personal differences with some others who thought that Sir Ashutosh is being too hasty, physics was introduced to the Science College. The three people involved in the starting of the physics department were S.N. Bose, M.N. Saha, and Shoilen Ghosh. Others joined: Sushil Acharya, Jogesh Mukhopadhyay, Phanindra Ghosh, and a person called Jatin Sheth.
This is Beedon Street in Calcutta. The whole Sheth family of Beedon Street was implicated in a shootout case, and Jatin Sheth was interned. Physics department lost one person.
Shoilen Ghosh, a fiery patriot, fell in the bad books of the police. He had to go underground and somehow managed to go through war-torn Europe to the United States. The fledgling physics department lost yet another person. 1919 was the beginning of another phase in Bose's life. Devendra Mohan Bose came back from Germany. He brought with him all the latest books and other publications. Bose started to learn German from him and study these books.
In the meanwhile, C.V. Raman too joined the Science College. He summoned the young teachers to join him in research. Most of them joined, except Shaha and Bose, because their forte was not experimental physics, but mathematics.
In the beginning, Bose and Saha collaborated to write a joint paper, which was published in the Philosophical magazine. Saha also worked out his famous paper on thermal ionization and was ready to go abroad, having received the Guru Prasanna Travelling Fellowship and generous financial loan from friends like P.C. Mahalanobis. Gyan Chandra Ghosh also received the Palit Fellowship and went abroad. Bose had all along wanted to go abroad for his studies. He tried again. He went to Sir Ashutosh and pleaded his case for the Palit scholarship. Sir Ashutosh smiled and said,
"But how can I? You're already married."
Palit fellowships were given to bachelors only. 1921 was another significant year. The University of Dhaka had been founded. This institution would prove to be very significant in the life of Bose. The Vice-Chancellor, Philip Hartog, was looking for teachers. Some high official had mentioned about Bose to him. So Hartog got in touch with Bose and appointed him reader in the University of Dhaka. It was here that Bose would write his paper entitled Planck's Law and the Light Quantum Hypothesis. This pleased Einstein so much that he translated it himself and published it in Zeitschrift für Physik. It was this that catapulted Bose into the international world of physics.
But world fame did not come under idyllic circumstances. Bose had immense problems in Dhaka precisely at this time. Dhaka University nearly halved the salaries of all staff. Bose was the only one who did not accept it. He protested. A committee was set up to study the case. It was precisely during this period, under very difficult circumstances, that Bose wrote his famous paper.
Bose sent his paper to the British journal Philosophic magazine. Not hearing from them for a while, and anxious to know Einstein's reactions to this novel idea, he sent a copy of the unpublished article to Einstein with this covering letter.
"Respected Sir, I had ventured to send you the accompanying article for your perusal and opinion. I'm anxious to know what you think of it. I do not know sufficient German to translate the paper. If you think the paper worth publication, I shall be grateful if you arrange for its publication."
That was the 4th of June, 1924. Exactly 28 days later, Albert Einstein wrote a postcard to Bose. He said,
Dear colleague, I've translated your work and communicated it to Zeitschrift für Physik for publication. It signifies an important step forward, and I like it very much. It is a beautiful step forward.
what was this beautiful step forward?
There was a theoretical conflict between Max Planck's quantum hypothesis and Einstein's light quantum hypothesis. And this is what Professor Bose resolved by showing that Einstein's light quanta had a new kind of statistics. Einstein welcomed it because it meant a significant step forward for his theory. He soon applied it to the atoms of gases and found that such atoms should have a wave-like character. Prince Louis de Broglie of Paris had already proposed such a wave-particle duality for matter. And Einstein drew everybody's attention to de Broglie's hypothesis. Erwin Schrödinger, who was also studying the quantum theory of gases in those days, began to wonder as to what the equation of motion would be for such matter waves, because Newton's equations were obviously not applicable to them. And he soon discovered that equation which goes by his name. And that is how modern wave mechanics or quantum mechanics began. Bose showed the way to go beyond classical statistics and opened up this new subject of quantum statistics. Soon, Enrico Fermi and Paul Dirac also developed a new quantum statistics. Particles which follow Bose's statistics have been named bosons, and those which follow the Fermi-Dirac statistics have been named fermions. Now, it has been found that all elementary particles discovered so far are either bosons or fermions. Nothing else has ever been observed. Bosons have a very special character. They are responsible for what is called superconductivity and superfluidity. Certain metals have been observed to suddenly lose all their electrical resistance when they are cooled down to near the absolute zero of temperature. Then they become superconductors and electrical currents can flow in them without any resistance. Scientists believe that it should be possible to use such superconductors to supply the entire power for a city without much dissipation and therefore without much transmission loss. Now, superconductors have another strange property. They expel magnetic fields. So if you place a superconductor over a magnet, it remains suspended. That is called magnetic levitation. Now, this principle can be used to run superfast trains. They are called maglevs, and they are already in operation in Japan and England. Now, although Einstein could not have seen all these dramatic consequences of Bose's statistics, he realized its deep significance. And he was very happy because it came as an unexpected support of his light quantum hypothesis. And that is why he quickly translated Bose's paper and sent him that postcard so promptly.
This letter of Einstein had a miraculous effect on the administrators of Dhaka University. Bose was given his full pay. In addition, he was granted 2 years study leave. He was even given more money than he had asked for his trip abroad. In October 1924, the long-cherished desire of Bose was fulfilled. He was able to go to Paris. When he arrived in Europe, he found that he was already a famous scientist. Einstein's German translation of his paper had already been published with his footnote, which said,
In my opinion, Bose's derivation of Planck's formula signifies an important step forward. I shall show elsewhere that the method used here also gives the quantum theory of an ideal gas.
Einstein published 3 papers between June 1924 and January 1925, in which he praised Bose's method and made all applications and extensions of it that were possible at that time. Everyone was reading these papers and discussing them.
But why did Bose go to Paris rather than anywhere else?
Bose was interested in the latest developments in X-ray crystallography and nuclear physics. At that time, Lawrence Bragg and Ernest Rutherford were conducting significant experiments in these very fields in England. The Vice-Chancellor of Dhaka University, Hartog, wrote to them recommending Bose.
But of course, there was no place for Bose in those laboratories.
Similar experiments were being carried out by Maurice de Broglie and Madame Curie in Paris. That was one reason.
There was yet another reason, the nationalist spirit of Bose.
In Paris, he stayed at 17 Rue de Sommerard in the Latin quarters. This was a hostel for Bengalis and happened to be the headquarters of a revolutionary group which had many branches in many European cities. Bose was a scientist, but not just a scientist. He was a patriotic scientist. He was conscious of the fact that he was sent by the University of Dhaka and he should go back and set up the physics department in the most modern way to make India as advanced and self-sufficient as possible. The fact that Bose had already become a world figure helped him. He worked with Maurice de Broglie, Professor Langevin, and for a while with Madame Curie.
The news of Bose's association with the Bengali revolutionaries of Paris reached India and Dhaka. The Vice-Chancellor wrote a confidential letter to Professor Sylvain Levy inquiring about Bose's activities.
Professor Sylvain Levy's remarks perhaps reveals in short what Bose was as a person. Professor Levy wrote,
I am not qualified to express an opinion on Mr. Shotendranath Bose as a physicist. Still, I can say that whatever I've heard about him from the most distinguished scientists here is a high appreciation of his abilities. On my own account, I'm glad to say that Mr. Bose is one of the most cultivated men I have ever met. He has a mind wonderfully open, bright, versatile, many-sided. I wish to add that he is also one of the most lovable men I know, and I'm sure that his influence on the students will be powerful and efficacious.
From Paris, Bose went to Berlin in late 1925, where Einstein included him in the famous colloquium. Bose used to visit Einstein in his small flat at 5 Haberlandstrasse. They had a lot of discussion on physics and other matters. While in Berlin, the news reached Bose that the highest post in the physics department of Dhaka University had fallen vacant. Bose's friends from Calcutta asked him to apply with a testimonial from Einstein. Bose had always considered Einstein as his master. When Bose explained the situation to him, Einstein wrote,
The recent works of Mr. S. N. Bose, especially his theory of radiation equilibrium, signify, in my opinion, an important and enduring progress of the physical theory. Also, in personal discussion with Mr. Bose, I've got the impression that he is a man of unusual gift and depth from whom science has much to expect. He has also at his command an extensive knowledge and certain ability in our science.
Paul Langevin, professor at Collège de France, wrote,
I have the highest esteem for the personal merit and the works of Mr. Bose, whose researches have been pursued here and whose presence has contributed to increasing the scientific activity of our university.
Then came a recommendation from Hermann Mark in no ambiguous terms.
Mr. Shotendranath Bose's large and profound knowledge, which stretches over the whole of physics, as well as the wider territory of chemistry, marks him out prominently. His most valuable quality, which makes him of inestimable value to a collaborator, is his deep and clear insight in the fundamentals of our science. His wealth of fruitful ideas and his capacity to combine theoretically important questions with experimentally feasible tests in an exceedingly happy manner. From the presence of Mr. Bose, our institute derives the greatest benefit, all the more as he understands in a masterly way how to make the most difficult questions clear through discussion, a quality which seems to make Mr. Bose eminently suitable, especially to the profession of teaching.
With such recommendations, it became possible for the university to appoint Bose a professor, although he did not have a formal doctorate. He would spend the most potent of his academic life here for the next 20 years.
back at the Dhaka University, Bose set up the physics department with emphasis on experimental physics. The two people who helped him were K. Banerjee and K.S. Krishnan. But just to do physics for its own sake was not being Bose. As a true scientist, he ventured into chemistry. But what triggered Bose to enter this field was a humanitarian consideration.
The wife of his friend and classmate Shoilene Ghosh suffered from some sickness which called for treatment with sulfur drugs. But such medicines were not available then. So Bose asked one of the students in the chemistry department to work with him to extract sulfonamide. This not only helped to cure the lady, but also resulted in the discovery of a new sulfur compound and a doctorate for the student, P.K. Datta.
It was the time of the Great Famine of Bengal. Being a world-famous scientist was not good enough for Bose. He wanted to be useful for his people, especially at this time of their dire need. It was at this time that a Chinese chemist came to India to study how Indians were making vitamin tablets. He ended up with Bose in Dhaka. The Chinese chemist was curious to know how Bose extracted sulfonamide and prepared the various compounds. Bose agreed to show him the method, but on condition that the Chinese would teach him how to extract milk from soybean. Bose thought that this would help the starving people. Science at the service of the people. This was characteristic of Bose. He was a theoretical physicist, but Bose made sure that he just did not get stuck in theories, but something that helped the people, helped India to become more self-reliant.
Bose lived in Dhaka for nearly 25 years. He was not only respected as a great scientist, but loved by colleagues, students, as well as the general public of East Bengal for his childlike simplicity and generosity. He returned to Calcutta in 1945 as Khera Professor of Physics. Besides a large number of public addresses he gave and popular articles, he wrote 30 technical papers spanning the period between 1918 and 1955. These covered such diverse fields as statistical mechanics, elasticity, quantum theory, mathematical physics, statistics, organic chemistry, X-ray spectroscopy, thermoluminescence, and a burst of 5 papers on Einstein's unified field theories between 1953 and 1955. Bose actually designed a spectrophotometer to measure thermoluminescence. He was hoping very much to go and meet Einstein in 1955, the 50th year of relativity theory. Bose reached Bern, but Einstein had died just 6 months before.
It is not possible to enumerate on what he did thereafter because there were so many of them. He made his services available not only to the university, but other institutions as well. For example, Prashanta Chandra Mahalanobis had started the Indian Statistical Institute. Bose helped him not only academically, but in its administration as well. Bose never swerved from his ideal, an ideal that forever guided his research, his thinking, and finally his life, namely, to make science serve humanity.
For example, around 1950, Bose had realized that solid-state devices were going to become important in everyday life. Germanium was required for this. India could not afford to import germanium, so Bose thought of extracting germanium from sphalerite obtained from Nepal. He appointed R.K. Datta to assist him with this work, and they wrote 3 papers on the subject. Although they succeeded in developing a method for extracting germanium, it was not taken up and commercially exploited in India. Bose realized that unless science is taken to the people, its purpose is not going to be fulfilled. But in order to do that, it was essential to vernacularize science. Already in 1947, Bose, together with a group of others, decided to set up an institution for this. It was named Bongio Vigyan Parishad.
After his retirement from Calcutta University in 1956, Bose was appointed the Vice-Chancellor of Bishwabharati, the brainchild of Rabindranath Tagore. Bose's attempts to introduce scientific research was not well received at that time, and he left before his term was over.
But true scientists always remain true scientists, no matter where they are. While at Shantiniketan, Bose used to visit a nearby place called Bakreshwar. This place is known for its hot springs. It triggered the scientific mind of Bose. He suspected that the gas contained significant quantities of helium, a rare but valuable gas required for research and industrial application. Later, in the 60s, Bose would engage Dr. Shyamadas Chatterjee to analyze the gas emerging from the hot springs. Dr. Chatterjee's measurements confirmed Bose's suspicion. Today, the Department of Atomic Energy has taken up the entire project. Bose looked at not only today, but tomorrow as well, and not a personal tomorrow, but the tomorrow of his country. He had been nominated member of the Rajya Sabha from 1952 to 1958. In 1959, he was nominated the National Professor of Physics, a position he held until the end of his life. He also received the Deshikottama and Padma Vibhushana awards. Eminent people began visiting Bose. They could be statesmen like Chu En Lai, or artists like Bishnu De or Jamini Roy, or scientists from various fields. The Nobel laureate Dirac visited him once. He had coined the word boson after Bose. He was surprised to know that not only was Bose not given the Nobel Prize, but he was not even elected a Fellow of the Royal Society. Dirac took up Bose's case, and Bose was finally made a Fellow of the Royal Society in 1958.
Bose was a complete person. He had a flair for languages. He was fluent in French and German. He was interested in the ancient Indian scripts as well. So his concerns did not end with the world of physics, chemistry, or mathematics alone. It extended to horticulture and the fine arts as well.
He used to play the Esraj every morning. In fact, he developed a new raga. Even as the various notes combined to give rise to a raga, Bose's entire life was a raga that he sang with vibrancy and melody.
Truly, Bose was a scientist with a mission, and that mission was to be at the service of the people. He lived to be a grand old man of science, a reference point, a person whom anyone could approach and be sure to find a friend.
As one of his students puts it,
Professor Bose was like the flowing Ganga. Any time one could take a dip and feel enriched. All knowledge seemed to be his province.
but Ganga too has to meet the sea where it all ends. In 1974, Bose completed 80 years. It also happened to be the 50th year of Bose statistics. There was an international meeting for this occasion in Calcutta. Scientists came from many parts of the world to pay their respects to Bose. At last, Bose was satisfied and said,
"I think now there is no need for me to live."
And that day came on the 4th of February, 1974. Bose breathed his last. If a person has to be judged by the work that he or she has done, Bose had done a lot not only in physics, but in other fields as well. But that scale is not sufficient to measure Bose. Bose was a man who stood head and shoulders above the rest and the best, not because there were no problems in his way, but in spite of them and in the middle of them.